Okay, so we are live.
Yeah, yeah,
Mm, Is my screen visible?
yeah. Your screen at the moment, yeah, it's visible. It's visible.
Okay, so our today's GFG question is we need to print a pattern in which we have been given a number in which first of all we have to decrement this number such that it's till 0. When it reaches 0 or below 0, we need to increment it by 5 so that it reaches its original state which was given to us. So we need to increment and decrement its number by 5 until it's reach 0. After that we need to again increment it. For example, I'll explain. For example, we have been given a number 16. We first of all need to decrement it by 5 until it reaches 0 or below 0. For example, 12, then reach 11, then it will reach 6, then it will reach 1, then it will reach -4. So as you can see, that number has reached below 0. Then we need to increment it by 5. Actually, 1, 6, 6, and then it will again give 11, and it will again give us 16. And we need to return this vector. So how we can do is, first of all we can store our original number in a variable and initialize a vector. Then we need to check if it's greater than 0. We need to push that number and decrement it by 5. After that we need to check if n is not equal to n. Then we need to push back again n and increment it by 5. After that we can simply return our vector. So let's try running it. Okay, so last number is missing. We can simply push it again. So yeah, it ran successfully. Let's submit
Okay,
it. Yeah, it got submitted.
okay, okay.
Okay, so now to use Sangam.
Just give me a moment. Yeah, so let me share my screen. So is my screen visible at the moment?
Yes.
Okay. So guys, the question that we have been asked today in our today POTD is that we have been given an array. It's a 2D array. And then after making some adjustment, we have to find the area of the largest matrix, or we can say the largest area enclosing having number of ones. So what does that means? As you can see in our given matrix, that is the example they have been given here, I've already drawn it here. So let's just understand it how we are going to solve this problem. So this is the thing that they have given us as an example. Now in this matrix, if you observe it carefully, if we just take it as it is, the way it is given to us, if we see or observe carefully, we're going to find out that here two elements are combined, here two elements are combined, and here three elements are combined. So either we can view this these three elements in terms of column, or we can view these elements in terms of row. If we take the count of the number of ones which are consecutive connected to each other, so in our given array it is 3. Yeah, because we are going to get either 1 2 3 we are going to take, or either we are going to pick the 1 2 and 3, because rest of them, if we see the pair of these two, it will be only 2. If we see the pair of these three, it will be 3. If we see this pair, it will be 3. Now the trick that they have provided us in this question is that you can make adjustments in terms of column. Now what does that means? That the array that I have been given here, I can make adjustments via column. What does that mean? That this column, the column that I'm marking right now, I can move it to here, I can move it to at any index and switch that or swap that column to the respective index with which I am replacing. And that is what we have done in this example. What we have done is that if you observe it carefully, this is a column which has three elements, and if you observe it in this array, in this 2D array, you're going to find out that this column had been moved, or it is moved from the last place to the middle place, and the middle row or middle column had been put in the respective place where the three elements who are consecutive at that point they were initially. So that is what we have done. We have made adjustments in this regarding, and via this adjustment what we have found is that if I now take count of the values that are given to me, if I take count of this value after this adjustment, I'm going to find out that yes, three elements are available at a particular column. Yes, but if you observe it carefully, there are four elements that are combined to each other, that are forming matrix, 2D matrix. So the area, before making adjustment, the maximum matrix that we can get was 3, but after making adjustment, the maximum matrix that we are getting, the size of the matrix is actually 4. So that is what this question is all about. They have given us an array, it is a 2D array, or either it can be a 1D array. So after making the changes, after transforming, after swapping the column of this matrix, I have to find the matrix which will have the maximum area. That is what I have to do. In this case it was 3, in this case it was 3, but after making adjustment it had now become what, 4. So that is what I have written. Now same goes for this example. If you consider this example carefully, this example they have given us, no they have not, yeah, this is the example they have given us here. I have just picked that one. So here we are given like 6 elements that are available in our this 2D array, 111 and 101. Now if you see or observe carefully, you're going to find out that two elements are here consecutively present, and also here two elements are consecutively present. And if you observe it carefully, this row or this element is just let alone living in his life. He is not connected with anyone, he doesn't care about anyone, so he is only considered to be one. But if we see in terms of area, that we have to find the largest matrix, you're going to observe it carefully that there are only two, or the area, maximum area that we can get in terms of matrix, it is only true. And even after making the adjustment, so that adjustment that we have made in this new matrix is that the last row had been replaced to the middle row, and the middle row had been put in the place where last row was. So after making these adjustments, still we are only getting 2 as an answer, and this element is still living his life like a legend, just alone. So the final answer that we are getting in this full matrix after making adjustments is only 2. So that is what we have to do, guys, in this case. Now you can do it via double for loop and by applying some conditions, if and else conditions. Yeah, that is, it is possible to solve it that way, but that actually is going to increase, or like the length of the code would be much larger. It will be like something like 100 plus lines of code, as I have already tried that method. So now I'm going to teach, or I'm going to share with you a new method that I have learned recently, and that method is much more efficient than the previously one that I have been talking about. So in this method, what we are going to do, this is the matrix that we have pick here. Okay, this is the one we are going to solve in here. So what we have done is that, first of all, after you looking at this matrix, what we have done is that in the column wise we are just going to add that element. We are going to take the prefix sum of those elements. So if you observe it carefully in this matrix, the first column had 0 as first, then the second element here available is the 1, and when we are going to look for the third row, we have to just add all the elements that are present before it. So in this case it was only 1, so 1 plus 1 we are going to get 2. Now in this case the first element is 0, now the second element is 1, and for the last element it is only also going to be 1, because we are just taking the sum of the previous element. That is what we are doing. Now in this case, in the last row, if you observe it carefully, the first one will be 1. It's an obvious case. Then the second one will be, because we are adding the element previously, so it is going to be 2, and then for the last case it is going to be 3, and that is what we have done in this case. Yeah, I have to make some adjustments here. Yeah, this one is 1. So if you observe it carefully, that is what we have done in this matrix. Seeing guys, that is what we have done. There is no changes that I have made. It is just what it is. No guys, but it will remain 0, because if we do any changes, and that is going to disrupt the way. Oh yeah, if it is 1, nothing will happen. So that is what we have done. Now the next thing that we are going to do is sort this matrix in terms of column row wise. So what we are doing is that the largest element will come in the first part and the smallest element will go to the last part. That is what we have done in this case. So in the row 1 you can see that only 1 is present there, only 1 is present, so that is why 1 is here. Now if in row 2, 2 was the bigger element, that is why it is here, then 1 1. And for the row C3 we have done the same thing, that 3 was the is the bigger, so that is why it is here, then 2, and then the last element, yeah, we can just make it as 1. There is nothing wrong with that. Now after doing that, so first of all what we have done, we have taken the prefix sum in terms of column. In terms of column we have taken the prefix sum, and then we have just sort them out. Now the third thing that we are going to do, or that will be the final step in terms of solving this question, is that we are going to take a variable name c, and initially the value of c will be 0. Okay, so that we don't get any kind of garbage value. And the second thing is that we are going to apply a for loop, but that for loop, or that loop will, in that loop the value will start from 1 and it will go till 3. So usually what has happened is that when we are doing the loop, here the value initially go from 0 and it moves till n minus 1. What we are doing in our loop is that we are taking the value from 1 and we are running it till the value becomes equals to n. That is what the one change that we have to make in order to solve this problem. So what we are doing is that we are just taking the count of this, we have applied the loop and we are just taking the count of the variable from 1. Then whatever value that is present in the array at that particular index, we are just going to multiply it to this value, to the value of the column, and we are going to see what is the result of it. If it is bigger than the value of c that it currently have, then we are going to accommodate the value of c to that index. If it is not, we are just going to just ignore the value. So let me just elaborate with you what we have done. We have taken a variable name count, then we are actually going to traverse in this array through row wise, okay, as we usually do in 2D array. Then the third thing we are going to do, at each row where I'm going to just multiply it, every element that is available in this row, I'm just going to multiply it to the value of the row it is in. So in this case, for 1, if you see carefully, for 1 it is present at what, it is present at column 1. So that is what we have done, 1 multiplied, and what we are going to get 1. For 0, it is present at column 2, so that is why 0 is multiplied to 2 and we are getting 0. And again 3 0 that is available at 3, we are just multiplying it and we are getting the result. And then we are just at count, we are just taking the value of max of count and comma whatever the value that we are getting after multiplication. That is what we are doing. The same goes for the second row. If you observe it for this row, the first element that is available here is 2, so 2 is being multiplied by the 1 because that is the column it is actually situated. Then the second element is 1, 1 is multiplied by 2 because that is the column where it is, and then again 1, it is multiplied by 3 because that is the column, it is it. Now observe it carefully. When I multiplied 1 multiply 2, I'm going to get 2. The value of originally count was what? 1, but here it is 2, which is greater than the value of count. So here that is why count had become 2. Again count become 2. Then after the multiplication I'm going to get 3, which is greater than 2. That is why the count value is 3. So this is the multiplication that we are keep on doing for our matrix. And after this multiplication what we are going to get is the answer that we are getting right now. So as you can see, this is the matrix. After doing the transformation we are getting 4 as an answer, and that is what we are going to get after doing this method of solving this problem. Now observe the second example. Here even after making the row adjustment we are still getting what? 2 as an answer, and that is what we have done. So first of all we are going to take the prefix sum. As I already told you, we are not making any adjustments here. 1, then it was 1 plus 1, so it will be 2, then again 1, so here it is 1, then 0, it will be 0, then yeah, it can be 1, it doesn't matter. 0 0 and then 1 1. Now after that we just have to sort it out. So after sorting it out we are getting this. Yeah, this will be 0. So after sorting it out we are getting this. Then again applying the same principle guys, and we are going to get the answer as 2, which was what here already described. So that is how we are going to solve this problem. The three-step process: first one is take the prefix count, the second one is sort it out, and the third one is do the multiplication of the element that is available at that particular index, that and multiply it to the row wise where it is locating. If it is available at the third row, then multiply the value that is available at that index to the 3 value. Again, if it is second row, multiplied by 2, and again if it is 1, multiplied by 1. That is how we are going to solve this problem. Now observe it that how we have done it. So first of all we have taken a matrix that is given to us. Then we have taken an integer m, which is just taking the column and the row size of this matrix. Then after that we have taken a variable name count. Remember it guys, I have already told you we are taking C for the answer, and here in our code, just to make it simpler for me to understand throughout this code, I have taken answer as that variable. Then I'm just going to traverse through my matrix array. Okay, and I have applied a condition here to just to check so that I am not taking the value of, like, if this is the matrix that I have been given here. Okay, so whatever value that is available here for the first row I am just taking a precaution that I don't take any garbage value of invisible row that is available. That is what I have done in my condition here, that if row is greater than 0, that is how we are going to take the condition. Then matrix of row column, in our matrix of row column we are just making the adjustment and taking the count of the prefix sum. Then along with that we are taking a variable vector, or we are taking a vector, and in that we are just storing the value of that matrix. Then we are sorting it out and then applying a for loop to just calculate the maximum value that we can get in order to solve this problem. Then after that we are going to return answer as answer. So that is what we have done. First of all we have just take the prefix sum, then sort it out. Then the third step was to find the value of those variable by multiplying it to the respective row. Now let's just submit the code. As already submitted, so it should work perfectly fine, but let's see. So as I have run the code, it is accepting. Now let's just submit it. So yeah guys, it is working perfectly fine as you can see. So with that, today we have solved both of the questions, the GFG one and the Leetcode POTD 2. We hope that it will be helpful for you guys. And with that, over to you, Shivam.
So yeah guys, thanks for joining with us. We will catch you up tomorrow.